Today I want to explore the options of mixed numbers and improper fractions in two different perspectives. I want to look at it through a process perspective and also a comprehension perspective. Whichever your preference does not necessarily matter, but one is just going to be more of a sequence type approach, whereas the other one is going to be more of a comprehension, understanding uh, approach to how the answers are derived from the original problem. So let's go ahead and get started. Here we have 6 wholes, 3/8. Here on the other side, we have 6 wholes, 3/8. After collaborating this year with a good friend, Miss Christy Spencer, she gave me an option of looking at converting this mixed number into an improper fraction using a method or an acronym or just a sequence process called math. Now, the M is going to stand for multiply, the A is going to stand for add, and the D is going to stand for denominator by keeping your denominator. So here in the process, the only thing that you will need to do is keep sequence of events. So in order to change 6 wholes, 3/8 into an improper fraction, I will need to first multiply the denominator by the whole number. 8 times 6 is 48. I just like to write my little notes to the side so that I can hold that better and I can see it. But we're not finished yet with this process. Now we need to go to add. Well, we need to take what we've multiplied, the denominator and the whole number, and add this to the numerator. So 48 plus 3, yes, 51. 51 is now my numerator, but the third sequence of events in this process tells us that we need to keep our denominator. There you have it. 6 and 3/8 is equal to 51/8. Now, for me and for many of you probably watching, this is how we learned in school. And there's nothing wrong with that. The process can get you to the answer more quicker, and it can be a more efficient way, especially if you are pressed for time, especially taking a test that is timed, or if you were doing some sort of round robin game in your classroom or with your own kids at home. So 6 and 3/8 is 51/8. And that's fine with the process. It's going to get me my answer. Now, if we look over here at the comprehension side, I should still get the answer 51/8. But let's go a little deeper with the comprehension. With this 6 wholes in my mind is going to be branched out 6 different avenues of wholes. And for me, the 6 different avenues of wholes are made up of 6/8 that will definitely equal my 6 wholes. Now you may ask, well, why use 8/8? Well, we always look to the denominator in helping us focus or helping us to understand the parts of wholes that we're dealing with. So if I count it by my wholes, 1 whole, because any whole number with the same numerator and denominator equals 1. 1 whole, 2 whole, 3 wholes, 4 wholes, 5 wholes, 6 wholes. Okay, that encompasses my 6 wholes here. And the 3/8, I'm just going to decompose my 3/8 into unit fractions. Now I can thoroughly see what 6 wholes and 3/8 is actually made of. Now, you may ask yourself, well, where does 51/8 come in? Well, it's all the same. If I were to count by my eights, help me count: 8, 16, 24, 32, 40, 48. Notice that this 48 is the same 48 as me multiplying the denominator by the whole number. Now I need to count from 48, 49, 50, 51. 51 is still my numerator, which is the top number of a fraction, and 8 is still my denominator because you always want to keep your same denominator. Here we have converted a mixed number to an improper fraction. Looking at a process, the process is just a sequence of events, a quicker way of solving a problem, whereas the comprehension way gives you a more in-depth comprehension, metacognition of where these numbers arrive from. Let's look at another example. Here I have 2 wholes, 1/7. Here I have 2 wholes, 1/7. In theory, I should come up with the same improper fraction because here I'm faced with two mixed numbers that are the same. In theory, I should still come up with the same answer for the improper fraction for both sides. Remember, the process side is just a sequence of events, of ways of getting you to that problem step by step in a procedural way. The comprehension way gets you to the answer in a more of an understanding type way. So, do you remember? Do you remember the acronym that we use? Right, MAD. Get mad. And I like to tell my students, get mad, and they remember. Okay, so here I have my denominator of a 7 and my whole number of a 2. 7 times 2, 14. I'm going to write my 14 there because trying to keep everything in my mind, it just disappears. So 14. But I still need to add. Let me make sure that I write down this roadmap of multiplying. Now it's time to add. Remember, we add the 14 from 7 and 2 to 1. 14 plus 1 equals 15. And remember, we keep the same denominator, 15 sevenths. Here we've converted this mixed number to an improper fraction using a process, some steps of events that will help us to arrive at the improper fraction. But if you want more of an in-depth understanding of what 15 sevenths is or what 2 and 1/7 is, that's when you can branch out those 2 wholes, because those 2 wholes are made up of 2 7/7. And the reason why it's 7/7 is because our denominator tells us what part of whole, what's the whole that we're trying to create here. 7/7, 7/7. Well, 1/7 is 1 whole. Another 7/7 is 2 wholes. But I still have this 1/7 here. I'm going to put it here. So now if I essentially count by my sevens, 7, 14, and add this 1, I still get 15. And remember, keep your denominator, 15 7. We're going to change gears a little bit. Now I've given you 2 improper fractions, 2 of the same improper fractions. We have 16/6, we have 16/6. The process for looking at 16/6 is, I wouldn't say use the math, because now we're dealing with more on the top, more on the numerator as we have for the denominator. So the process here would just simply be divide. Okay? We're going to divide. Now, our dividend, which is the amount that we have, the whole amount that we have, which is going to be our 16 that we're trying to distribute. And our groups, or our divisor, will be 6. Now we've just created just a simple division problem. When we count by 6, 6, 12, 18, oh my goodness, we can't go 3. We have to only go 2 wholes. Because looking at the grand scheme of counting by your 6s, 6, 12, 18, notice I have went over the allotted 16 amount. So I need to kind of go back to see what my closest number that I can get to 16 without going over. Let's continue. Now we just follow the process of division. After we divide, we now multiply. 2 times 6 is 12. After we have multiplied, we subtract. 16 take away 12 is 4. Here in this sense, we're actually finished with the problem, but we have to convert this into a mixed number. Converting this into a mixed number, this 4 will now be my numerator, keeping my same denominator, which is 6. 2, 4, 6. Now, with the comprehension way, I've kind of shown you over here on the procedural way, but looking more in depth, if I were going to count by my 6s, 6, 12, 18, and I could continue and extend this pattern, but for the sake of trying to get you to just understand the comprehension side of converting this improper fraction to a mixed number, if I'm counting by my multiples of 6, I cannot land on 16 by counting by 6. So therefore, I have to stop the closest that I can get. And stopping the closest that I can get is 12. So that's going to be 1, 2 times that I can count. And now if I look at, okay, I have my 2 wholes, but I'm still trying to make it to 16. Now I can say 13, 14, 15, 16. And if I counted these, 1, 2, 3, 4, I know that I will still have 4 numbers, or 4 6 left over, because 18 is my next multiple, but my improper fraction is 16/6. Today we've used improper fractions and mixed numbers by showing how we can solve an improper fraction and mixed number using a